Good evening, and thank you all so much for being here this evening. We are so excited to be able to bring this rare disease forum to folks here in this room, and then also we have 90 people registered to view our webinar that's casting at the same time virtually. So we're really excited to be able to bring the expertise of the panelists and our speakers here this evening to share their insight and their knowledge and their wisdom. My name is Ellie Hayes. I'm the Executive Director for the Missouri Cures Education Foundation. We're a nonprofit organization that works to promote and protect medical research across the state. We make sure that any research that's legal at the federal level remains legal here in Missouri. And we bring these educational programs to you to share the wonderful research that's happening around the state and to bring people together to discuss that research and just to educate you about the work that's happening all across the state. We have incredible research facilities here, institutions. We have Washington University, where we are, hosting us tonight. Thank you so much. We have SLU here in Missouri, or in St. Louis. Then there's the Stowers Institute in Kansas City. Of course, there's the University of Missouri all across the state doing great work. There's the Children's Mercy Research Hospital in Kansas City. So we are home to many really incredible research institutes. So it's my pleasure to be able to bring this research to you. I'd like to introduce our moderator for the first, I'm going to introduce Deanne Stalling. She is our partner here today with Rare and Black, and I'm going to let her talk for just a moment about Rare and Black.
Thank you. Thank you so much. Good evening, everybody. Thank you for joining us here in person and online. I'm so excited because I do a lot of traveling throughout the country, and I feel like St. Louis is the best place to get treatment. It's the truth. There's some doctors here that see patients all over the country. So it's wonderful to have this event at this place with these people to be able to discuss some of the rare diseases. We can't touch all 12,000, but we can make a dent, and I believe that this region between Kansas City, Columbia, and St. Louis should be a powerhouse in rare disease research, rare disease treatment. Rare and Black is an organization that makes sure that Black people have a voice at the table when it comes to treatment, access, and research. And it's not an anti-anything organization, but we just want to make sure that everyone at the table is represented. So thank you for coming.
Thank you, Deanne, and thank you, Deanne, for helping us to secure this space, and we are very grateful to her. It is my pleasure to introduce the moderator of panel one, Dr. Adriana Montano. She is the Vice Dean for Research and Professor of Pediatrics and Biochemistry and Molecular Biology at St. Louis University School of Medicine. Dr. Montano is an internationally recognized scientist who has made outstanding contributions in the field of MPF research. Dr. Montano has over 27 years of research experience on lysosomal storage disorders. Her research has set the basis for understanding of Markio A disease and fly disease by providing insights into the natural history of patients showing heterogeneity of phenotype and genotype. In addition, she has developed mouse models for Markio A disease, instrumental to carry out preclinical trials to assess novel treatments for the disease, including enzyme replacement therapy, gene therapy, and substrate reduction therapy. Her work also includes the discovery of biomarkers and the development of newborn screenings for patients with MPF, which is fundamental for early education and treatment of patients. Dr. Montano received her Bachelor of Science degree from the University of Los Andes in Bogota, Colombia, and PhD degree from Gifu University in Japan. She received a postdoctoral fellowship from the Japan Society for the Promotion of Science to study molecular evolution of keratin sulfate and peptoglycan recognition proteins at the Graduate University for Advanced Studies in Japan. She has served as a postdoctoral fellow in the Department of Biochemistry at Kobe Pharmaceutical University in Japan, where she studied chondroitin sulfate metabolism and hyaluronidase. Did I get it? I got it. Dr. Montano received a Master's of Science degree from St. Louis University in Health Outcomes Research and Evolution Sciences with a concentration in clinical investigation. It is my pleasure to introduce her and the rest of panel one.
Well, thank you so much. It's a pleasure to be here, and I am honored to be in a place like this with all of you. So tonight we have three panelists that will share with us a little bit about gene therapy and rare diseases. For all of you who have questions towards the end, you can ask questions to the panelists. If you are via Zoom, please write your question in the chat box, and then we will answer the question towards the end. So I wanted to introduce our guest panelists. So first I will start with Dr. Christina Gornet. She's the A. Ernest and Jane G. Stein Professor of Neurology, the head of the Division of Pediatric and Developmental Neurology at Washington University in St. Louis, and the Chief of Neurology at St. Louis Children's Hospital. She completed her MD and PhD degrees at the University of Iowa, then came to Washington University in St. Louis for pediatric neurology and neurophysiology epilepsy training. She is also the co-director of the Washington University Intellectual and Developmental Disabilities Research Center and the associate director of the Institute of Clinical and Translational Science, or ICTS, in 2007. She has an active neurogenetics research program that includes a multi-center genome sequencing study of African Americans with scoliosis. In response to the COVID-19 pandemic, she led 2 rapid acceleration of diagnostics in underserved population projects to study SARS-CoV-2 testing at schools for children with disabilities in the Special School District of St. Louis County. She also co-leads a new R25 program for underrepresented high school students to gain exposure to pediatric neuroscience. Thank you, Dr. Kovacs. We have also Dr. Susana Gonzalo. She received a degree in biology and biochemistry from the Universidad Complutense de Madrid, and a PhD from Washington University School of Medicine. Under Dr. Linder's leadership, she studied the role of post-translational modifications of neuronal proteins in their localization and function. After a short postdoctoral fellowship in Dr. Dean's laboratory here also at Washington University in St. Louis, studying the retinoblastoma family of tumor suppressors, she received an NSF International Postdoctoral Fellowship and joined Maria Blasco's team at CNIO, a top cancer research center in Spain. During these years, her team demonstrated for the first time the epigenetic regulation of telomeres. In 2006, she was recruited to Washington University in St. Louis as faculty of the Radiation Oncology Department, where she developed a research program studying the crosstalk between nuclear architecture, chromatin structure, and genome stability. In 2012, she joined the Biochemistry and Molecular Biology Department at St. Louis University School of Medicine, where she is currently professor. Her research interests include understanding the molecular mechanisms that contribute to the genomic instability that drives aging and aging-related diseases, such as cancer and cardiovascular disease. Special emphasis is on a very rare, accelerating aging disease known as Hutchinson-Gilford progeria syndrome. Thank you, Dr. Gonzalo.
Thank you for being here.
And finally, we want to introduce Dr. Fumihiko Fumi Urano. He's a physician and medical researcher specialized in Wolfram syndrome, which is characterized by juvenile onset diabetes, vision loss, and neurodegeneration. Dr. Urano is a professor of medicine and pathology and immunology, an attending physician at endocrinology genetics clinics, and currently holds the Samuel E. Schechner and Dow Professorship in Medicine at Washington University Medical Center in St. Louis. Dr. Urano is a driving force in the study of Wolfram syndrome and related disorders. As the director of the Wolfram Syndrome and Related Disorders Clinic and Study at Washington University Medical Center, Dr. Urano has been leading the clinical, translational, and interventional studies of Wolfram Syndrome and related disorders. Dr. Urano's contribution with colleagues at the medical center and around the world has allowed him to develop cutting-edge treatments for this disease, including gene therapy and regenerative therapy. Thank you so much. Well, I would like to start with some questions. Could you please start by giving us a brief overview of your involvement in gene therapy for rare disease? Dr. Urano, can you start, please?
Okay. First of all, thank you, Ellie Hayes, Ms. Ellie Hayes, for hosting this important meeting, and Dr. Montani for a kind introduction. So I have been working on a rare disease called Wolfram syndrome, characterized by juvenile onset diabetes. So they need, all of our patients need to take insulin injection. And they also develop optic nerve atrophy, so they gradually lose their vision. And also they develop neurodegeneration, so they lose the ability to move around, and eventually they lose the ability to breathing, then they die. So it's a terrible disease, and it's a genetic disease. So single gene change, the name of the gene is called WFS1. So single gene change causes this terrible disorder. So we have been trying to correct the gene changes. We call them pathogenic variants, or some people call these mutations. We try to correct mutations in cell models and animal models of Wolfram to see if we can restore the functions of brain, eyes, and insulin-producing pancreatic cells. And so that's what we are trying to do. And eventually, we want to bring this technology to our patients to cure the disease. So that's what my team has been working on in the past several years.
Thank you.
I think it's amazing time to be doing anything in medicine. Having seen the genetic revolution, where now my patients have a genetic diagnosis, where 20 years ago it was a symptomatic diagnosis. So I think just first of all to acknowledge where we are and the possibilities are amazing. My work right now, I do a lot of gene discovery, but I'm also very interested in making sure that we can identify variants in people and know who should get the disease and who or a treatment and who should not be getting a treatment. As you all know, some of the gene therapies are $2 or $3 million. Some are very risky, so you don't want to give them to someone who doesn't need it, but you also don't want to miss the opportunity of treating someone. I'm also very passionate, and I've worked with Dion and feel like we really have to bring everyone along on the genetic diagnostic journey. We can't leave populations behind where we don't do genetics at equal rates in all populations. Everyone has the chance for being involved in clinical trials and having so that's my interest, is really trying to figure out who can get these treatments and making sure we're getting them to everyone.
Hello, so thank you again for the invitation as well. And I work in a very, very rare but very dramatic accelerated aging disease. So these kids, if you meet them, they are fantastic because they are so full of energy. Their body, so let me tell you, they are born normal, and within 1-2 years of age, they fall off all the charts of growth, and then they start developing alopecia. They lose all the hair everywhere in their body, and then they slowly develop all the aging phenotypes throughout their bodies, except the central nervous system. It is never affected. And also another interesting characteristic is that they never develop cancer. So originally it was thought that maybe because they don't live long enough, but that doesn't seem to be true. It seems that they have some protective mechanisms against cancer. So what usually happens is that these kids develop aging phenotypes all over the place, and then they eventually die from cardiovascular complications. So they develop very big masses within the aorta, big calcification of the aorta, the heart, etc. So eventually die. They rarely pass 30 kilograms in weight, so you can imagine they are thin, short, and with total aging phenotypes. Now, my lab is studying more the molecular mechanisms, like what are we have the cells from the patient. What? Oh, now, okay. So we have the cells from the patients as well as a mouse model that carries the same mutation. And with respect to this mutation, is a point mutation. So it took forever to identify the cause of the disease. A point mutation, a C to a T in an exon. So, so for many years, the only thing that they could do is treat the symptoms, but no cause of the disease. So now that we have the cause and we have the mutation, I wish it was my lab, but it's not my lab, but David Liu in Harvard, MIT, has developed base editing, which is a technology that uses CRISPR and is developed with adenoviruses to change the point mutation and change the C to T to back the G. C. But I suppose we are going to talk more about the specific. But that is what I do, and there are only, I would say, 300 to 400 patients in the world. So 1 in 20 million. So it's very rare, but it's so dramatic that there are a lot of people invested in this group.
Thank you so much. So Dr. Cornet, can you please share with us some recent breakthroughs in gene therapy that have shown promise to treat rare disease?
Sure. So just overall, in general, you should know there's a distinction between in vivo gene therapy, where the gene therapy is delivered to the person's body, versus when you take the gene, something from their body, probably blood often, and then deliver it ex vivo, which are more often done for cancers or metabolic disorders. For brain disorders, which I treat, we pretty much need to deliver those gene therapies to the tissues where the individual needs that either replaced or modified. There are different ways of doing the gene therapy, and I'll use spinal muscular atrophy as the biggest breakthrough in my lifetime for gene therapy. This is a disorder in its severest form that was uniformly fatal by the first year or two of life, and I saw many kids die of this. In a pretty horrific death where they lose the ability to move and unable to breathe or swallow. There are now 3 different therapies out for this. One is an antisense oligonucleotide, which is an RNA-based therapy that had to be given as a spinal tap. And it had to be given and still has to be given every 3 months to modify the expression of the gene that can make that disorder a lot better. A couple of years later, we had approval of a one-time gene therapy, which is in an adenovirus vector that's given once by IV. It's the one and done therapy. This is the $2.1 million gene therapy for spinal muscular atrophy. Those kids who got either of those treatments now are in their 4, 5, 6 years old. It's a relatively common disorder, so we see it and deliver these therapies every month. And those kids are doing really well. So that's what's motivating. I think we all know that there's going to be other challenges, and there have been additional gene therapies that have run into problems with hydrocephalus when some of the antisense oligonucleotides were given to some children. There have been another muscle disease where they had liver problems after receiving an adenovirus vector that was lethal in one of the children. So we're optimistic, but we also know there's going to be a lot of challenges to be able to deliver therapies to the 12,000 rare disease, and we have to figure out how to do it more efficiently and reach more people.
Thank you. So, Dr. Gonzalo, can you share with us some alternatives to gene editing, such as therapies that can affect molecular mechanisms that contribute to the genomic instability?
Yeah, I mean, there are many therapies that we are testing, and usually what you do is you take, again, the cells from the patient, I suppose, or the mouse model, and then first you do the experiment with the cells, try different drugs, and then if something works in vitro, you treat the mouse. So what we were surprised to see in our the last 3 years of our research is that 2 compounds that were relatively safe. One is vitamin D, and the other one is anti-inflammatories. One, especially baricitinib, is just an anti-inflammatory that many people take for rheumatoid arthritis or some autoinflammatory diseases. So they are FDA approved for other treatments, and in the cells and in the mice, they have an impressive effect in increasing the life of the cells and the health of the cells and the lifespan and health span of the mice. Because at least in my disease, one of the things that happens is that, as I guess the same as with the aging population, we want to live more, but we want to live well, because if your health is very bad, so the health span, extended health span for the kids with progeria is very important. And we see that with these 2 treatments, baricitinib and vitamin E, we can extend both health span and lifespan. So what is the idea? And what, as David Liu is improving this gene therapy, the idea is to combine gene therapy with something that is not toxic and that both together can, because after all, I don't know how it's in your diseases, but in progeria, the best gene therapy that has doubled the lifespan of the mouse. So a mouse with progeria lives 200 days. With base editing, this change lives 500 days. And this is the double, but only 20 to 60%, depending on the organ, of the cells in that organ, were cured or the mutation was reverted. So at the end, you are not going to have 100% efficacy. So then combining with additional therapies is important.
Thank you so much. So as you mentioned before, Dr. Garnett, many of the kids that have rare diseases are born with a normal phenotype. And many parents and physicians spend lots of time trying to understand what is the diagnosis of the disease. So can you please share with us what is the potential role of newborn screening and gene therapy to manage the outcome of rare diseases?
Yeah, using spinal muscular atrophy is probably the best example, because we do have a treatment that can prolong quality of life and life for those children. Missouri was the first state to get newborn screening for spinal muscular atrophy about, I think, 3 or 4 years ago. Now every state, except I think Alaska, is probably coming. And you know, this is a challenging disorder because you're making a diagnosis on a really healthy looking child, newborn infant. But we do know from studies that the outcomes are better the earlier you get the treatment. So we're going to have many more examples of where we're going to want to do these kind of extreme therapies early, but you have to be entirely certain of the diagnosis. You don't want to put someone at risk or miss this if you need to give it early. For Duchenne muscular dystrophy, another disorder that affects mostly boys who are very young, and also early lethal disorder. Newborn screening for that is just starting now in Ohio, for that same reason that I think getting these therapies early is really important.
So Dr. Urano, can you share with us the importance of patient engagement in research and development of treatments like gene therapy?
Sure. So the patient engagement is critical actually for developing any new therapies, including gene therapy. And so we have been closely working with multiple patient organizations with Wolfram syndrome. And there is one in Missouri, which is Snow Foundation. And actually head of the Snow Foundation, Stephanie Snow-Gabriel. She was supposed to come today. Yesterday. But we have been working closely, and so that it's important for get patients or patient organizations getting involved. The reason is we need to know what patients want. So for example, Wolfram syndrome patients develop different types of symptoms. They have diabetes, they have low vision, and they have some neurological issues. They have bladder problems, hearing issues. They have so many problems. But there is a most bothersome symptom shared by maybe 80 to 90% of the patient, which is low vision. Then should we target diabetes? Should we target, bladder issues? We should target low vision. Then we should develop gene therapy for low vision. So it's very important to work with patients and patient organizations to understand what they really want. Also, if patients or patient organizations are heavily involved in research, when we set up a clinical trial, we often need help from industry partners. And then when we set up the collaboration with industry partners, if patients are heavily involved, the industry partners are more willing to work with us because they are touched by stories, by patients. So it's very important to work with patients.
Thank you, Dr. Cornett. Can you share your experience? with us?
Yeah, I think anyone who sees patients, as a pediatric neurologist, I have dozens of families that I'm working with, some that are right here that, their passion and their willingness to try to convene and identify other patients to improve our understanding of their condition is so necessary and admirable to what we do. And a lot of these are nascent disorders that are I have one family I'm working with, that there are only 5 people in the world with this disorder. And so those needs are just as great as the disorders that cause, tens of thousands of people. And so we trying to figure out how to really bring everyone along. It's really important.
Thank you. So as you know very well, we have the Orphan Drug Act, right? That, helps to incentivize industry to invest in rare diseases, by giving some extra conditions. But Dr. Urano, can you share with us a little bit about efforts between researchers, clinicians, industry to make sure that working, with FDA, we can move treatments faster and we can deliver to our patient population?
Sure. So that's really important question because industry partner, patients, and doctors and researchers should work together to bring any new treatment, including gene therapy, to our patients suffering from difficult rare genetic disorders. And so the reason is, so as an academic scientist and academic physician, we know less about the regulatory approval processes. So, we can do a lot of research in mouse models, cell models, and we can characterize our patients deeply. Then we can come up with potential new treatment, and maybe including gene therapy. So we can do a lot of things in academic, medical center. And however, to bring these new technology to patients, we know less about regulatory processes, regulatory approval process. Then the industry partners, they usually have strong regulatory team or teams to get the drug approved, a new gene therapy get approved. Also, patients should get involved. Reason is that when we create a clinical trial protocol as an academic scientist, so we write up a protocol, and then the industry partner reads it, then edit. We also need to show, we are currently doing it for a drug, medication trial. We show the protocol to our patients to see they like the clinical trial processes. Because maybe sometimes, okay, this looks like a really good protocol for academic doctors or industry partners, but patients may think this is too much for us. It's impossible for us to come every 2 weeks for your medical center. Or, I want you to check these things. So it's good to get feedback from patients. So we created the patient vote for our ongoing clinical trial to get their feedback.
Mhm.
And Stephanie is one of the.
So, Dr. Gonzalez, do you have any experience, anything you want to say about, the importance of having patients involving these processes?
Yeah, I can tell my personal story. When I started my own lab, I want to share just because I feel so lucky to be working in this disease. But what defined that I work on this disease was one patient. So I had my first lab as independent researcher here in WashU, in fact, and I started working in the mutation of this KIS, that is lamin A. But I was working in many other things. I was working in cancer, radiation therapy, etc. And as a side project, I had this project with lamins. No, okay. So I go to the first international meeting in Vienna, and then it's all about lamins. So I wanted to learn. I learned a ton. And then there was a family with a kid with progeria and the parents. So when the meeting was over, we were at auditorium, maybe 150 scientists. And then this kid, 13 years old, but at that point, the average lifespan was 13 years old. So then he, in front of the whole auditorium, starts talking to us, thanking us for all the effort that we were doing, because he was in the maximum probably life that he won't see a cure or an improvement, but he wanted to thank us all for our hard work, blah, blah, blah. So this year, 23, I went to another, then after that, first the whole auditorium was crying. Many of us decided to work more in Nigeria, and so we changed our lives. My scientific life was changed like this. And this year, 2023, the meeting was in Madrid, where I'm from Madrid, so the international meeting on laminopathies was in Madrid. This kid, Sami Basso from Italy, 27 years old, gave a science a speech of his science because he's doing the PhD on progeria. We were all like goosebumps and whatever. It's like, look, if I don't do anything else, at least it was such a satisfaction. So the patient has such a power on us that I just wanted to share with you.
Thank you so much.
No problem.
So, gene therapy is something really exciting, something new that is happening. We, as researchers and scientists, are working really hard to make sure that, more diseases can be included in clinical trials and get approval. So since we have had such a long journey with gene therapy, Dr. Urano, can you share with us if you envision gene therapy transforming from, clinical trials and such a, moving so slowly into becoming part of the standard of care of patients with rare disease?
So I think for genetic disorder, gene therapy will be a standard of care or part of the standard of care in the next 10, maybe 5, 10. Actually, it's becoming standard of care for some genetic diseases such as sickle cell anemia or some form of the leukemia. And it's part of the standard of care. And for genetic disorders affecting many different parts of the body, such as brain, in the case of Wolfram, it affects brain, pancreas, and also the eyes. So there are multiple tissues affected, right? So I believe gene therapy will be part of the standard of care, many genetic diseases. But there are some challenges, especially diseases affecting different parts of the body, including brain. So then the reason is how we deliver gene therapy components, such as for gene editing, we have to bring in small piece of DNA together with enzyme. How we bring these components to different tissues? Should we target all the tissues? Well, some specific tissues? These will be a major issue in the next 5 years. That's my impression.
What do you think, Dr.
I think it's exciting to see things move forward. There's definitely some hesitation. There are some structural birth defects, that at least at birth. Some of the features probably can't be reversed even at birth. And so I think we're gonna have to accept there will be some that won't be as easily treated with gene therapy. And then I think you also have to talk about the spectrum. You know, I treat patients from very severe, with severe neurologic or neurodegenerative conditions. I also treat some patients with autism that is pretty mild, and those families, and those patients, they don't want to be changed. And so I think the industry is certainly prioritizing disorders that are very severe, lethal, and from a financial gain, a lot of them are looking at the more common conditions. And so we, again, have trying to figure out a model that's going to work for all these different disorders that are so very heterogeneous. It's our biggest challenge.
And, you know, price is a challenge at the moment, right? You know, we want a therapy that is cheaper, that, you know, patients and families can access easily. And, you know, what I think is another of the challenges is late onset disease presentation. So do you have any comment about that?
So I do have some comments about late onset disease.
Mm-hmm.
So for late onset diseases, early diagnosis is very important.
Mhm.
So how early should we diagnose these patients? And then, so when should we start treating these patients? That's the challenge. And also, genetic diseases, we diagnose them by genetic testing. And when we conduct genetic testing, we find many gene changes. And some gene changes could contribute to the pathogenesis of the disease, but some gene changes are not related to the disease. So genetic testing should be accurate, because if we misdiagnose them and if we start treating them before they start developing symptoms, that's harmful, right? So because if we misdiagnose them, if we give them gene therapy, that could be harmful. So genetic testing should be pretty accurate. And also, when should we start treating them? Should we start treating them when they are born? Or should we treat them even before they are born? You know, so these are the questions we should have some answers.
Yeah, that is a very good topic. So now there are some approaches in utero trying to treat the fetus when, you know, it has been diagnosed. So I think that is something to look for. To ensure that our gene therapies are affordable, and patients with rare diseases can get benefit from those. Do you have any comments, any suggestions?
You know, I think as a society, we have to figure the cost benefit, which is really challenging. I mean, the incremental, you know, I think most of us would say in theory, we don't want to pay $3 million for incremental benefit that might prolong someone's life by 3 months, you know, whatever small amount. But you can also counter that and say, we've done therapies where a child who couldn't feed themselves now can feed themselves. And that's a really big quality of life change. And so, but I think we are going to have to decide as a society, and I think insurance companies are already doing that to some degree and deciding what they'll pay for and what they won't, based on benefit.
Well, and you know, an important topic that you brought up a little bit ago was the nature of the involvement of different organs and tissues in the body and how we can target that. So I don't know if you can mention a little bit about targeting the vector, the viral vector, or how we could make tricks in the lab to make sure that we can target the right organs while taking advantage of others. I don't know if you have.
I could say a little bit about the amount of work that is being done. There is even a company that is called Beam Technologies, probably maybe you guys know better, where they are developing the spectrum. So they are, so I guess you guys know that there is a CRISPR-Cas9 is the mod, that is the nuclease that is gonna cut the DNA and introduce the base, change the mutation, revert the mutation. So the amount of research that has been done in the last, I don't know, since early, 10, 15 years, trying to find the best combination of enzymes that can cut the DNA, but not too much, because you don't want to be cutting in places that you shouldn't cut. So the elaborated technology that they are developing is insane, and also the delivery. So the enzyme itself that is gonna fix the DNA, but also the delivery. And I think that there, if I'm not, if I remember correctly, this week there was a Nature paper that was showing that you could deliver some of these genes without the need of a viral vector, because there is a lot of controversy about the viral delivery. But now it seems that they are developing ways with lipids, liposome, microparticles that can deliver the enzymes without the virus. And I think that's the next step, that we are going forward.
I
People know
completely
more than
agree.
that.
I completely agree. We used to use, actually, we are still testing adeno-associated virus mediated delivery of different gene therapy components. But now we are also testing nanoparticles, lipid particles. And so we try to deliver, gene therapy reagents to different tissues using different technologies. So in addition to virus, we definitely need other technologies, and we should work with biomedical engineers to develop new technologies, and we are working with it. So that's a new area, and that's an active area of research in gene therapy.
But did you feel that is moving fast? Because I feel that it's moving
Moving
really
pretty fast.
fast.
Moving pretty fast.
And every story and every disease is going to be a little bit different. There are some gene therapies that are now being delivered by neurosurgeons right to certain parts of the brain. The eye is actually pretty accessible for gene therapy. So every disorder, you'll see innovations in different spaces that may work well for one disease.
Thank you so much. So I want to open this for discussion, for questions. If we assume we have some questions, I think we have time. Some of them.
I'll start it off. How often does your research in these different fields and different diseases that you focus on have read across to potential solutions or improvement to other diseases? What have you found? Have you found read across or across your research that impacts other?
Yes, that's a great question. So rare genetic disease, many people think, okay, you are working on Wolfram syndrome, and you can only help small number of patients who have the disease. So that could be maybe 1,000 people in the United States or 1,500 people in the United States. Is it worth doing it? It's definitely worth doing it to save these patients, small number of patients. But in addition, if we find a new treatment of optic nerve atrophy, low vision, seen in patients with Wolfram, we can potentially use exactly the same treatment for other people who are suffering from low vision. Low vision itself is not rare. There are many people who have low vision. So diabetes is the problem in patients with Wolfram. Wolfram itself is rare, but diabetes is pretty common disorder. And we can potentially use the treatment that we developed for patients with Wolfram could be utilized for the treatment of diabetes in general. And so that could happen. It has not happened yet in my rare Wolfram disease, but that our treatment or new treatments developed for Wolfram could be utilized for other, medical conditions.
Right.
So that's actually, that could happen in the future. And that's a really important question and point.
Good.
Thank you. Thank you for raising that.
In our case, that is an aging that is just fast, accelerated. The mechanisms that cause normal aging and the mechanisms that cause this accelerated aging are very similar, with little differences. So it gives us a great tool, for example, have mice that instead of aging in 2.5 years, age in 100 days. So then in 100 days, we can treat, we can do, and we don't have to wait for treatments, whether it's gene therapy or normal therapy for so long. So the mechanisms are the same. So we are learning a ton about normal aging, studying this rare, very rare aging disease.
Thank you.
I have a question. This is coming from a non-biological science person. I would like to know, I'm involved in a lot of genome and gene, I know nothing about any of this. I'm trying to figure out is when you, in your research, when like Chris said, there is something that may cost $2 million. Is there some kind of, I'm trying to figure out when you are sourcing the drug, is that what's driving the cost or is the demand driving the cost? And in your research, do you find that you try to find different ways to make things more accessible?
You know, I think the high cost is driven by all of the research and development. A lot of that happens in universities, a lot of it happens in industry. The clinical trials are so very expensive to follow these patients up for sometimes years and years after the gene therapy, that's really where the cost is. I think it will come down there, the antisense oligonucleotide, a lot of these same methods can be used, and adenoviral vectors, once they've been used a couple times and safe, you know, I think some of the safety studies that they're having to do now probably won't be quite as in-depth down the road. So I think you're gonna see a lot more disorders come on board in the next couple years.
And is it all private funding or is there something that we can advocate on
You know,
federal or state legislative?
Thank you for bringing up, that's a great point. You know, the National Institutes of Health always needs public support for research. Right now, about 1 in 10 research grants that goes to the National Institutes of Health is funded. The rest are unfunded. Those are projects and cures and cell studies in cells and mice that aren't being funded. So more funding for research on the private level would be great. You know, and industry funding is also, I mean, they're partners. We have to partner to be able to get these rare diseases therapies.
Probably for Dr. Gurnett as a pediatrician on the call. Do you foresee whole genome sequencing being the newborn screening of the future?
I actually do think that's going to happen. Right? There's a lot of reluctance now to do something like that, but I think it will end up being cost effective. We're already doing whole genome sequencing now for diagnostic purposes. I think it's going to be 5 years, but I think it will.
To tie into that, how about adult whole genome sequencing prior to reproduction? So because these rare diseases you say are inherited, so typically parents don't have it. So how do we inform the parent?
That's a great question.
Possibility of transmitting this.
You know, at some point, I think we will all have our own genomes, and so we will know our own liabilities for our offspring. It turns out for a lot of neurodevelopmental disorders in children, a lot of those are new mutations that happen where both parents don't have that variant, but it happens in the sperm or in the egg. So there are a lot of, in fact, most of the patients that I take care of, there's no way to predict ahead of time. They're random events, similar to how cancer is very random, built based on just a single change that happens.
Any other questions?
I just have one more question, kind of piggybacking off of kind of cost and how to offset costs. Like in the grand scheme of things, I mean, is it your guys' opinion that, you know, at some point the research costs and the high costs of some of these medications, if they're able actually to significantly prolong life or offer some level of cure for some of these diseases. I mean, in the grand scheme of things, you know, as these patients are progressing in their disease, their healthcare utilization increases dramatically, and therefore the associated healthcare cost to the system as a whole increases. I mean, presumably at some point, like there's going to be a tipping point where the cost of the medication is going to be much less than the overall cost of the system if that disease is not treated. I mean, is that a shared opinion?
I think that's a great point. I mean, I think that's what healthcare economics is gonna have to weigh in. I think the biggest challenge is gonna be really the clinical trials that show just a tiny bit of benefit, and yet the drug companies to recover the cost of doing that expensive trial. They're gonna be exorbitant costs for really mild improvement. And yet I think every parent in here, if it was your child, you'd want that mild improvement.
And your point is well taken because, rare diseases or genetic diseases are basically chronic diseases. So they have multiple problems throughout their lives. And some patients may die early, but some patients may live very long. The cost for the medicine will be very high. So on diabetes, all these patients need to take insulin every single day for 20 years, 30 years, 40 years. And if we can cure diabetes, then they don't have to pay for insulin, and that's gonna be good for the society. So the one-time treatment, which could cure or significantly improve the symptoms, would be actually, even though that's expensive, could be actually cost-effective. So that's a really good point.
Yeah.
A question from online.
Oh, yeah, go ahead.
If you find therapies that are successful in research and trials, how long does it usually take until those become available to the public?
The clinical trials often, someday, like for spinal muscular atrophy, I think it was within days, the trial, once it's FDA approved, the therapy becomes available immediately.
I just have one more question. Do you find that, especially with maybe ultra rare, like she said, she only sees 5 people in the world or country with this, some illnesses just need like a jump start, like a car that needs a battery, where they only need like 1 treatment or 2 treatments to get better, to just get over the hump? Would that be something that we could look forward to? Or because rare is rare and ultra rare is ultra rare, there's not a lot of data. I know doctors love data and researchers love data, but if there's not anything or anything with a name, how would you be able to get that jumpstart the baby or the adult if they got diagnosed with a long medical odyssey? If they just need something to get them over the hump into a clinical trial, just to be able to get what they need. Case in point, immunoglobulin therapy for people with chronic inflammatory demyelinating polyneuropathy. They may just need that if they're not able to walk, they need 5 treatments, and now they're able to walk, but that treatment is so expensive that, nobody really wants to pay for it.
I think those are really challenging questions. I think when you talk about ultra rare disease, I think there's some real opportunities because we've got great scientists who sometimes have been working on these problems for a long time, and finally when they find a patient who can benefit from all of the knowledge, sometimes some disorders move very quickly because that scientific base we already have a handle on at the time that the first patient was diagnosed with it.
Well, I think we're gonna leave it there. Thank you so much to our panelists. They were good. And I'd like to invite the second.
We have time for a potty break.
Very much. We'll be back at 7 o'clock. Go ahead.
Yes, right. Hello.
Yes. Story. Yeah, he could run. And I want to make sure. Yes. I didn't know. You want us Yeah. Oh, we don't want to have. I say I understood, but I don't have. A very big voice. I don't know. Everybody hear me? They So. Yes. Nobody got anything done.
Well, I want to thank all of you for coming around and, again, just thank you so much to panel one. What great conversations. I feel like I learned a lot. I hope you did too. But I'd now like to introduce, I'm very excited about our next panel. They're going to be talking about bridging the gap from pediatric care to adulthood care. And first I'd like to introduce our moderator. We have Kristen Lastoff. She is a patient advocate and a parental advocate, and then she's also the founder of United for Rare. We're really excited for her to be here today moderating for us. We have Natasha Hickman-Foister. She's also a rare disease advocate and a parent of children with rare disease. We have we have Michelle Oliva. Thank you. She's the nurse navigator for genetics and rare disorders at Washington University School of Medicine in the Division of Pediatrics. Then we have Dr. Monica Muir. She is the assistant professor of pediatrics, palliative and complex care at SSM Cardinal Glennon Children's Hospital. And then we're very excited to have Rosemary Britz join us. She is also a patient advocate and a parental advocate. And she is the executive director of the Sickle Cell Association here in St. Louis. So welcome everyone, and we're very excited to hear.
Thank you, Ellie. Hi, everyone. I'm Kristen Lastoff. I'm a mom to 3 kids, 2 of which are living with a rare condition. I'm also the founder of a parent caregiver community network here in St. Louis called United for Rare. Super honored to be here among all of you, but especially this panel of women. I would love to have them introduce themselves and give a little bit of background. So let's start with you, Natasha.
Hi, my name's Natasha. I was the co-founder of EDS St. Louis Support Group. I was born at Ehlers-Danlos, and I have a very unique way of looking at all this. I have 3 children, a 30-year-old, a 15-year-old, and a 13-year-old. All 3 were born with EDS. So I have gone through this transition, and I'm back for a second round of going through this transition. But I didn't know EDS even existed until I was 30 and my oldest was 14. So I had to deal with that transition much later on with her. And I know the differences that I'm now changing in my younger 2 to make sure they're very much more prepared for adulthood dealing with what we deal with.
Hi, thank you for having me here. My name is Michelle Oliva. I have been a nurse for 23 years, an RN in pediatrics. I started working on the floor in neurology, transitioned to a clinical nurse coordinator in neurology, where we had a lot of rare diseases. And since then, I've now transitioned. I worked in a clinic treating, again, neurology patients with rare disorders, working as a supervisor. And then now I work in genetics as the rare disease nurse navigator for our Center of Excellence designation. Dr. Muir.
Hi. And again, really grateful to be here and be a part of this panel. So I am business-based training, internal medicine, pediatrics, and then hospice and palliative medicine training. I've been working primarily with pediatric patients that have complex illnesses, life-limiting and life-altering illnesses for the past, I think almost 6 years or so. And that's been like I said, at this point, this has been my life work. I'm very passionate about that patient population. Because I'm internal medicine trained as well as pediatric trained, have worked with them, have worked with patients as they have aged out of the pediatric world and into the adult world, and kind of understand how traumatic that transition can be. And I myself actually also have hypermobile EDS. So.
I am Rosemary Britz. I am the founder and executive director of the Sickle Cell Association. We serve the state of Missouri. I also sit on the rare disease board for Medicaid for the state of Missouri. My journey started with giving birth to a daughter that lived with sickle cell and not knowing anything about how that happened. And as I learned more and raised my daughter, I was urged to start an organization to help other parents through that process. And so that's where I found my passion in helping other people to hopefully avoid some of the pitfalls that I may have come to, as well as just helping the individuals themselves to live their best life possible. Unfortunately, my daughter did transition about 4 years ago at the age of 29, but I maintain my passion because there are individuals that are still living with this disease or may be born and parents needing that support. So I'm glad to be here today.
Amazing, welcome. And just a quick reminder, if you have questions, we'll hold till the end. And then if you're joining us virtually, thank you. Please use that chat feature when we're opening it up to the audience. So to start, Natasha, can you talk about your experience as a caregiver to a child with rare disease who's transitioned into adult care?
So because we did not find out with my oldest until she was 14 about EDS, you know, I went the very typical route. You take your kid to the doctor, you do the talking, the doctor talks to you, the child sits there very patiently, and then you leave. And in doing that, you're not really preparing a child who has, you know, a rare genetic disorder on how to navigate the adult world with doctors. We don't teach them at that point that they have a voice. They need to use the voice. They need to be able to be firm when they need to be firm, be gentle when needing to be gentle, and understand that although I have great respect for doctors and physicians, but you're not gods. You don't know everything. You can't. It is impossible. So as a patient, we have to know. We have to know about what we have. We have to know about maybe the offshoots of what goes with it. POTS, for example, is very common with EDS. Chiari's malformation, which are two things that I have. HLA-B27 I have, and those are all things that can go along with EDS. We have to know those things because we have to go to so many different doctors. We don't have one doctor, we have 5 doctors, 10 doctors that we have to go to. So with having my last 2, I'm teaching them to go in and say, okay, this is how I'm feeling. This is what's going on. This is what's bothering me the most. To speak up when needed if they feel like they're being disregarded for something, and to be very good with paperwork. A binder, organized with every piece of paperwork that you get when you leave a doctor's office, because that binder is your Bible. You go to the next doctor, you take your binder. That way you can sit down and go, I have done this, I have been here, I've had this test, I go on this medication. To know what tests they need to have, how many years down the road have their echocardiograms done. There are just so many aspects that goes with it that doctors don't think of because you focus on one, where we have to get our kids to focus on everything. And it's overwhelming for kids. It's overwhelming for parents.
Rosemary, can you speak to your experience, and was it difficult to kind of take a step back and allow your child?
Absolutely. One thing that I find in having a child with rare disease is that we as parents hold on to the child very tightly. And so that includes making their appointments for them and speaking up, like she said, speaking up for them and keeping track of everything that they've gone through, and then rambling this all off to the doctor. If they go to another doctor, telling them what kind of medications and that kind of thing. And so in transitioning, the child is lost. And then I thought that as my daughter would transition into adult care, that they would take this whole medical record and look at it and maybe stay with what was already going on. But no, she went in and I allowed her to go by herself to first appointment, and she comes home popping all this medicine that was not, it's like, that was not a part of your plan. What happened? It's like, oh, well, we didn't need to look at that. This is what we do for all adults. No, don't put my kid in, you know, like everyone is individual. And so we should approach things that way. She didn't know to say, no, that's not what I do. Why am I taking this? And that kind of thing. So it is very difficult in the transition process. And then when you hear maybe the horror stories from my viewpoint of what that adult side looks like. So you're going from unicorns and rainbows to this gray sky, and it's a scary thought for the child and for the parent. And a lot of times the parent is getting very anxious about that process, and then it spills over to the kid, and then they're like, wait, no, I don't want to go. What do you mean? You know, so it can be a very difficult process in transitioning into adulthood.
I think that's a great point. It's more of a family dynamic, right? It's not just about the patient, it's about the parents, even the siblings that are involved as you navigate. My kids are not old enough at this point to enter into this space, but this is incredibly informative for me because they will be at some point. Okay, so Michelle, what unique challenges do you see patients with rare diseases facing when transitioning from pediatric to adult?
There's a lot of challenges, of course, if we discuss them already. I think something unique that I deal with kind of on a regular basis are insurance challenges. So things are covered in pediatrics and suddenly you're an adult and they're no longer covered, or there's an insurance change and trying to keep up with those changes. I know my biggest struggle right now is with metabolic disorders and getting access to formula for adults or supplements that aren't covered by insurance. And so oftentimes I have to go through, you know, other resources like NORD to help pay for like medically necessary things for people just so they can function. I think another component are, you know, some of our adults are intellectually disabled. They don't know how to navigate the system. It's hard for anybody to navigate the system. And if you have some intellectual disabilities, now suddenly you're responsible and you don't have a great caretaker by your side, like a parent to support you, you know, you're kind of on your own. And so this is where, you know, I try to step up, at least for our genetics patients, to help fill out their paperwork, call, you know, the insurance company, call the resources for them. Because, you know, it's just too big of a challenge. And then they're non-compliant, and then they're going to be even more confused because they're not taking their medication. So it's, you know, an ongoing struggle. I do think we're doing some good things. There is a transition program through the Neurology CP Clinic. It's newer, but they have a great plan. You know, they start the transition period around 16 to 17. They meet with both the pediatric cerebral palsy provider and the adult provider like 4 to 5 times to make that transition nice and smooth. There's other programs through sickle cell now where they transition, but it's very kind of isolated based on the diagnosis. It would be great if we had like a blanket transition plan for all, you know, rare disorders. That doesn't exist yet, and it requires a lot of manpower, a lot of resources. And so I just think it's something we'll continue to talk about, but we are making good kind of measures forward so far.
Hope we get there. Be great for everybody. Natasha, can you speak to, from the parent side? I know you spoke a little bit about the challenges, but just having gone through it yourself.
You know, the parent, from the moment you find out you're pregnant, you are very, all you think about is the health and happiness and raising the child right and all these wonderful things. And then you find out that your child is sick. Not just a cold, but your child is forever permanently sick. It's going to evolve. It's going to get worse. So you go on high alert and you start doing all the research, and you find scary things, and you find things that are reassuring, and you find misinformation, and you don't know where to look, and you don't know what to do. And God love the doctors that we have, but you do not have 5 hours to sit in the room with us. That's just not feasible. It would be great. I know you guys would love to do it, but it's not feasible. So, you know, we have to navigate this horrible world for our child and then turn them over to be an adult. We have to turn them over. We don't just at 18, we're not just getting them ready for college. We're getting them ready to find a different doctor, possibly in a different state, a different town, a whole new care team. So it's not just worrying about making sure they have the correct color comforter to go, to go with the person they're rooming with. It's to make sure that they have the ability to get their medications, to see their doctor when they need it. Are they gonna take their meds? Are they gonna go to the doctor? If they get sick, can I make it to them in time? Because all those things are worries that as us parents, we worry about. And then at 18, we're supposed to stop because they're adults. That doesn't work. I have yet to meet an 18-year-old that is completely capable of managing their medical care at 18. I love it. It's a unicorn. So we have to figure out how to get them transitioned, how to help them, and walk that fine balance and that fine line of making an adult, but still holding on just that little bit. And we also have to deal with the depression that goes along with it, because it hits us hard. Because we are turning loose of something that is so precious. Think about the parent with their first senior going off to college. They're depressed, right? They're upset. Well, we have built our whole entire lives around taking care of our special needs child. Our child that at a moment's notice, we're rushing to the ER because they're coughing funny, because they've dislocated a joint by standing up, because the common cold has hit them in a way that it doesn't hit everybody else. You know, we go through all those emotions and more because we are turning them loose, knowing that we cannot protect them. And I tell a lot of parents, it's okay to cry. It's okay to waller. It's not okay to live there, but it is okay to every so often go, this is my day to cry. This is my day to feel guilty because I don't feel like I've done enough for my child. This is my day to say, I feel guilty because I passed this genetic monster onto my child. It's okay to have that day. You just can't live there. And it's okay to let your kids see you cry about it because they need to understand you don't have to be stoic all the time. It's okay to cry. It's okay to scream. It's okay to throw a fit. You just pull it back together and we go on.
Dr. Amir, can you add from the professional side, what are the many challenges that you see?
Yeah, and again, a multitude of challenges, and I think that the challenges are uniquely different when you're talking about an adolescent transitioning into the adult world that is going to be able to continue to make their own medical decisions and kind of own some of that versus somebody that is not, and where the family, as soon as they turn 18, they're going to have to pursue guardianship. And they're gonna have to have all of the paperwork and all of the legal stuff. They're gonna have to get a lawyer. They're gonna have to have the money to pay for that process. So that's a challenge in and of itself. And I've been in situations where for some odd reason, someone had advised a parent against that. And we were trying to place a child that really needed to go somewhere where he was going to be able to get again, 24/7 kind of comprehensive care. We couldn't do that because the mother didn't have legal guardianship. And so that was really a challenge. And so I think that that's, again, one unique challenge for patients with rare diseases, in particular ones that again, aren't able to speak for themselves, that really are going to continue to need that parent to serve as their legal guardian and medical decision maker moving forward. I think on a system level, I think there are so many problems. It's so unfortunate, and this happens even within like adult hospitals and within pediatric hospitals. Care is so siloed. It is so siloed. Cardiology doesn't talk to nephrology. It doesn't talk to pulmonology. It doesn't talk to genetics. And it doesn't talk to the primary team that's taking care of the patient on the hospital floor. Nobody's talking to anybody. And this is true in the outpatient world as well, where a patient will call whoever their medical home is, and they'll have a pulmonary problem, and that medical home team will try to micromanage that problem, but nobody talks to the pulmonologist. And so care is really siloed, and and that siloing happens again within both the pediatric world and the adult world, but it's really bad in that transition. Pediatric providers generally don't talk to adult providers that have reason to unless they have a kid that they're transitioning. And so they may not even have a team or a provider that they would know to or communicate to transition. And I think that that's a part of how that transition happens. Like you said before, again, getting them involved early and starting that transition process early. Like you said, medical records don't always follow with somebody. And if they do follow with somebody, that adult provider doesn't always read those medical records. So they don't know what treatments that the patient has received, what medications they've been on that have been effective or that have been tried that haven't been effective. And so there's like, well, we do X, Y, and Z, and so this is a box that I'm gonna check. So many providers I would say in the adult world in particular, really don't feel comfortable taking care of patients with primarily pediatric problems. And so I think that you just have a paucity of providers that are, yes, of course, I will take them, like I'm willing to accept them. And I think that happens both in the specialty realm, as well as the primary care realm. And I think that most of us who've ever tried to find a primary care provider in the last 10 years for adults, man, it's not easy. Like there's not that many adult primary care providers. And so like that just compounds the fact that this patient that may have had a medical home, whether that was in, like I said, a primary care type of setting or a specialty setting, they don't have a medical home anymore. In the midst of that transition. So they don't necessarily have a captain of their medical ship. They don't have anybody to go to. I can keep going.
No, I know. You perfectly transitioned into the next question. So I'm gonna actually ask Rosemary this. For how can healthcare providers and patient advocates collaborate to ensure a smooth transition process?
Well, I think working with the both those entities, working with the patients and the family, preparing them early on, like this is going to happen, ready or not, okay? And preparing them for all of those life things, going through those processes of what do they need to know as an adult, you know, like going into that adult care. It's kind of with sickle cell in particular, when you get to the adult side, suddenly the same people that had been caring for you previously, they no longer believe that you have the pain and the complications that you're talking about. You suddenly become this drug seeker because you are now on the adult side. And so preparing the patient for all of those things. And so the physicians working with the advocates, working with the advocates groups. So like with my organization, we provide like a transition group quarterly where we get the adolescents together and try to talk about some of these things. What does that look like? Do you know how to pick up the phone and make an appointment for yourself? Helping the parents to even understand, like Natasha was saying, when you go to an appointment, instead of you going in there and spouting off everything, let the child go in there themselves, see the provider, and then tell you what they thought the provider said. And then see how did it translate? Did they get it right? You know, so that now you can know if this child is able to fend for themselves in a sense, going to their appointments. So I think that it just takes this group approach of working together with the physician, the advocates.
And likely starting it earlier on.
Yeah.
I had actually ironically situation today with my 9-year-old who has Chiari malformation, and she was asked about her diagnosis and she didn't know how to answer it. And so I, after talking with her, said to myself, I need to do a better job of educating her on a 9-year-old level and, start empowering her to take control or a little bit more control over what her diagnosis is, because she's gonna live with it forever. And now at 9, if I can do that, then maybe by 17, 18, she'll be armed with all that knowledge, so.
We started that early, even in camp, you know, talking with your kids about what medications they're on, why do they take them, when should they take them? Because they can't go into somewhere and say, oh, I take blue pill. Well, that could be a whole lot of things. So, no, it's not a blue pill, it's
This is what I
at
take.
this amount, you know, when I take it. So there are a lot of things that, you know, you start early and just allow them to grow into that process. And that is the child and the parent, and it takes the physician and the advocates kind of rallying around them.
So something that we found, that worked really great in the EDS St. Louis support group was we started a list on our Facebook page of recommended doctors. That was absolutely amazing, because you could go to that list, know that this patient, this EDS person has already gone to this doctor. They love the doctor. It worked out great for them. Now, mind you, there's a personality that has to mesh with your doctor. But it was great because it was something that you could pull from and say, okay, we're gonna go try this doctor. And also teaching our kids that just because you make an appointment with a doctor doesn't mean you have to see the doctor. That you can actually call and say, I would like to interview this doctor. Doesn't go against your insurance, but you get that time to sit down and see if you mesh. And those are important things to teach our kids, you know. Hard things because we forget. You know, we tend to think that we just pass that knowledge on to our kids through the umbilical cord. We forget. You know, and so finding your tribe, finding the group that's good for you to help you. Oh, hey, have you tried this? Oh, hey, have you made that binder or talked to this provider or done this with the insurance company? Those are also important. You have to find your tribe, your group that's going to make it work, that's going to embrace you, that your kids can get together with their kids so that they have kids that are alike with each other, that they can keep up with each other. Because I know your daughter was probably like my kids. They couldn't run outside all the time. You know, we have to have activities of laying in bed, days that life just doesn't go our way and the pain's too high and those hard things.
And just to interject briefly, I think the other piece, as providers, we is the minute the kids can start answering like realistic questions, we have to be, we're not asking the parents anymore, right? We can verify, but we have to engage the children
and
in
believe
the
them.
clinic. Yeah, and empower them in those.
Just to add to that.
Go on.
Sorry, no, there is like readiness assessments out there. There's, you know, kind of step-by-step instructions. You can access resources on how to transition if you're just like, we haven't had this discussion, I don't even know where to start. I know gottransition.org has a great website full of like a step-by-step, how do you transition. It's adaptable to every situation. I'm sure some things might not fit with your scenario, but you can adapt it. And I think just knowing it's out there.
Sure. One of the things we discussed previously is, are there checklists out there? Are there resources that literally give you the step by step? Okay, and I touched on that briefly right now, but are there other resources that we can share and provide as we're navigating?
Yeah, I just recently went to a meeting last week with the Centers of Excellence, and it was a checkoff form for like sickle cell patients. Rosemary identify with this, but it was amazing. It was, you know, all the different tests they'd have, when their last MRI was, when their last their medications list, their durable medical equipment provider. That's really important. Their insurance, when was the last change? Like, it just kind of gave this beautiful list of kind of the recent medical history and a little bit of past medical history that is really would make that transition go a lot smoother if you can provide that kind of information. Yeah, but you know, unfortunately not everybody has access to that. But you know, it's just something that if we could make that available to people, it would transition smoother.
I mean, as the kids get closer and closer, and same as you, if physicians would go, okay, you know, we're getting closer to the step. These are some resources, this is the printout, because not everybody has a Facebook page that a group that they're in, or a support, any type of support, and they're going this alone, and they don't know where to go, and they don't know how to look, and they look to physicians to help us. And I know you guys are doing amazing jobs, and you are helping us with that little extra, just that little extra to go, we're 14, let's start looking at what life's gonna look like at 8.
I will shamelessly plug the United for Rare website, which is a big reason why I established it was, as we've talked about, all of these rare diseases are very siloed and the community networks around them are very siloed. So we don't have this one-stop shop for rare diseases on, okay, you know, you recommend X, Y, and Z, and I recommend this. This is the place we can compile all of this. And that was my hope with this website and this group, is to be able to provide all of this information, because even though our paths might be different, we're still enduring a lot of the same things, especially from, you know, the anxiety, the things that come with parenting children with rare diseases. Just having that connection is a really big, important thing that I think was lacking. So go visit that website.
Thank you for that. It is needed.
Yeah, hopefully we can grow it, right? Okay, so let's see. So I'm gonna ask all of you this question. What is one recommendation or takeaway that you can provide that can improve the experience of transitioning for individuals?
Binders.
Okay.
Teaching them how to be organized with those binders, with all that information. And, you know, because if they're in a wreck, I can't be there. And somebody needs to know what medications are on. Somebody needs to know what's going on inside their body, because you can't see by looking at me that I'm disabled. You can't see by looking at me that I live in 24/7 pain. You can't look at my 15-year-old and know that she's on the spectrum and she has EDS and there's days she can't walk. So binder. Get that information.
Maybe if someone can create an app.
There are apps.
Are there?
Mhm.
Okay.
Yep.
Good to know. Well,
Yeah.
binder and app.
Binder and app. Having a hard copy is really nice, because if the phone is broken, that way.
Good one. Oh,
Yeah.
Okay, Michelle.
One thing we didn't touch on is a lot of times, you know, a kid turns 18 years old and the parent calls us and starts telling us about their headache or their seizure activity. And then I have to tell them, I need to talk to your 18-year-old now. And I can't give you medical information. They're like, oh. So just having that conversation when they're 17 or 16, whatever, their visit before they turn 18, and be like, hey, if mom still wants to be involved while you're in college, perfectly fine, because the kids usually don't want to talk to you. They might maybe a little bit, but most still want you to deal with mom and that, you know, which is fine. But you have to have a release signed. And so just kind of knowing that, to have that signed before they turn 18, you can still have that interaction with the provider. Because a lot of times, you know, pediatricians will keep the kids, you know, a lot of them through college. So you're still interacting, you know, with the pediatrician and the parent.
I'm gonna say kids don't even like to pick up the phone and call their friends.
And my recommendation is really plan. And that is multifaceted plan. And again, for some of those kids that are gonna need guardianship, I usually talk to families, start talking to them, like at 14, 15, 16, that these are the things you're gonna need. You need to identify a lawyer to do all of that stuff. And then you know what paperwork you're gonna have to get that. Usually start talking at that point about like establishing living trusts and like who is gonna take over guardianship if something happens to you, because a lot of these patients, as they're aging into the adult world, their parents are aging as well. So doing those types of things, but also planning too from a collaborative standpoint, like who are you transitioning to? Who is that team? Who do we need to talk to on that team? Can we introduce you to that team? Can we have a couple years of, or a couple of visits at least of overlap with that team, so that you can begin to learn that team, learn how they work. They can start to learn you as a patient or family, and you can build trust, because if there's no trust, That's gonna break down as soon as that transition happens, and that's when you get, they're not gonna be as adherent to the testing or treatment or those types of things. That trust is broken down. So there has to be a plan for all.
So I was gonna say start early, but I would
Sorry.
say also, no, I will say, helping to create that village or that support system early on, and that is for the child as well as parent. So like I said, our team transition group, so that they know that they're not alone and that there are other individuals that are going through this, maybe getting them into some sort of self-care management program so that they can learn those things that they need to know, but more so having that village or that support system together so that they know that they have someone to rely on and lean on, and that they're not alone.
So that is our panel discussion. I'm gonna open it up. If anybody has a question? Ellie, oh, sorry. What are we doing? Shoot first. Okay.
Oh,
Go ahead.
thank you. So, just thinking about the group of diseases that I work with, which are the mucopolysaccharidosis. Now there are treatments. So there is enzyme replacement therapy, and we know that enzyme replacement therapy extends lifespan. So before we knew that a patient with severe phenotype, may die really early, but now we know that they live longer. And physicians are not educated into, oh my God, now this patient is living longer. There are new things that are coming up. What about, I want to hear from you, discussion about pregnancy and fertility, because before those topics were not discussed even. But now it's something new that,
I would say I had 13 miscarriages between my 30-year-old and my 15-year-old. Doctors just told me it's, just happens, come to find out. I also have MTHFR, which I'm sure is a clotting disorder. I also have polycystic ovarian syndrome. I have a long list of things wrong. And it all falls, I call it under the umbrella of EDS, because EDS is here and then I have all this other stuff that comes down from it. But I didn't get the opportunity for any type of genetic testing or anything like that, because I didn't know till I was 6 months pregnant with my last child. I wish I would have known, because I don't know if I would have had a child that was biologically mine. Not to say I don't love my children. I love them to death. I'm tickled that I have them. But not only is it knowing that I passed this monster onto my kids that I think of as a ticking time bomb, because I never know what next thing is going to pop up. Is it going to be POTS for this child? Is it going to be Chiara's malformation found in that child? My son, who's 13, he needs, surgery on both feet because his feet are completely flat. So I passed this ticking time bomb onto my children, and I don't know if I would have done that. I know that now we are getting closer to figuring out for EDS, all the different reasons why, how, and when. And you can go in and check each embryo to make sure it doesn't, and I would have done that, but then we're talking about cost effectiveness. And there's not a lot of families that can afford that either. So we're entering into the realm of, you can't adopt, because if you're disabled, you can't adopt a child. Law won't allow it. You can't foster a child. Law won't allow it. So how do you build your family if you want children? You can't afford to have the embryos checked, can't adopt, can't foster, and you have to roll the dice if you decide to get pregnant. It's scary.
Something that we didn't really talk about, but I know we talked about when we met previously, was transitioning disability from childhood to adult care. Would somebody maybe talk a little bit about like the challenges of getting disability care for adults versus for children?
Well, disability as a child, for your child is a lot easier to get. You're not gonna get, you don't get a check because monetary is based off of parents' income. But you will get the insurance, which is vital, you know, when you're talking about high cost of medications and high cost of hospital visits and doctor's visits. But when they turn 18, if they already have disability, it is a much smoother transition, and they are highly more likely to get that disability as an adult versus waiting until they're 18. You're possibly looking at a 4, 5, 8-year battle to get it. It took me 5 years and going to the Missouri Supreme Court and getting shot back down to the lower courts twice before I was awarded my disability. So that meant for 5 years, I did not have one penny in my bank account coming from me. Everything was from my husband. And even after you get your disability, there's still a waiting period. There's 6 months before you even get one disability check. There's 2 years before you get insurance. So that patient, you know, they don't have means. That disability check does not mean that they're able to afford anything. Disability doesn't cover medications. I know a lot of people don't realize that, but it doesn't. It doesn't cover your medication. It doesn't cover vision. It doesn't cover dental. And you're still paying every month for your insurance. 1 year, my increase of living did not offset the increase in my insurance, and I ended up getting $30 less a month. That's scary.
This is a question for Dr. Murr. Silos sound dysfunction. I retired as an Amazon leader, or Amazon, you may have heard of the company. We couldn't function.
Every once in a while.
We couldn't function our different divisions and everything I had to leave if there were silos involved. What do you think needs to be done, or what is impacting that silo impact that you mentioned in your field?
I wish for something other than egos. But I think that's a big piece of it. I mean, I think that a lot of the times when you talk to people, you say like getting physicians to agree on something is like herding cats, and it really is that way. You know, I've had adult patients that were seeing their kidneys were failing. And their kidneys were failing because their heart was failing, and the nephrologist will come in and be like, "Oh, we're doing dialysis, and so like your kidney numbers are looking better. Everything is looking great. Everything's fine." And then the heart doctor would come in and it's like, "Oh, we have you on this medication infusion, and so your heart function is looking better, and everything's looking fine." And I'll come in and be like, "So we can't continue to do dialysis unless we're on this continuous infusion that's maintaining your heart, and we can't do any of this outside of the hospital. So nothing is fine." Like, so I mean, and that's just a really salient example, and because nephrology is, the kidney doctors aren't talking to the heart doctors. I don't know why. Like I said, other than for it to really be ego in a lot of ways, that this is, and part of it is like a staying in your lane, I think, issue. Everybody's afraid to get out of their own lane. Like again, if somebody is a cardiologist, like I'm a heart doctor, I just look at the heart and I only look at the heart and that's it. And they don't say, well, like, again, like, yeah, you've got them on 20 medications and their heart is functioning fine, but they can't walk, they can't breathe, like they're not living a life. Like, what is their quality of life? You know, nobody, like, they're all looking. I think that their view of the patient, in addition to their practice of medicine, is also very siloed. I think doctors historically, they want to fix things. They're presented with a problem, they want to fix things. And again, like, because their scope is narrow oftentimes. Again, I have this problem, I fix it with this. but then they're not taking that step back and looking at the big picture. And I think we need a lot more people, that are willing to take that step back and look at the big picture and say, no, wait, like we need to collaborate. And I think that I admittedly biased, as somebody that is palliative care trained. I think palliative care docs are particularly useful in doing that and taking that step back and saying, wait a minute, what does our life look like? And what are your goals? And how do we get from where we are right now to those goals? Palliative care is sometimes a bad word because it can be synonymous with hospice, and everybody thinks that hospice is a bad word, but it's not. But again, I think that having providers that are willing to take that step back and look at the whole picture and not just say, you have this problem, we're fixing it, and then that's it. So people, like providers, that are going to be invested and invested long term. And I think building good comprehensive medical homes is going to be a big piece of that, because they're going to engage with a physician and a nurse practitioner and nurse navigators, and social workers and dietitians and respiratory therapists, and all of these different specialists, that can then communicate with all of these people, all of these the patients, additional providers, and again, to make sure that there is collaboration, make sure that we're on the same page. And I think moving to like a comprehensive medical home model is going to be the thing that unsilos stuff, but I still think you're going to hit a ton of barriers along the way. I wish I had a more optimistic view of that.
And real quick, to the other learned persons on panel number one, isn't there a leadership initiative to more cooperation between all the different fields? Is there anybody driving away these silos? That seems so, everybody here in this room knows how common sense that is. Is there somebody with the leadership, vision, authority, whatever you want to call it, to drive these walls down?
I think we do, like, for example, for some patients, let's say a patient with Morquio that needs to have a surgery. It's not just a surgeon. So usually when we have a patient with Morquio undergoing such a big step, we need to have the genetic counselor, we need to have the surgeon, we need to have the cardiologist, anesthesiologist. So we, in some cases, we work together. I mean, they include me there as an expert in the field regarding, okay, do you know what is the complication of this type of patient in the surgery? This is not just like a regular surgery that you're used to. So I think we are starting to, work together with our peers, addressing those issues. But it's something that I think we have to start working ourselves and build ourselves to benefit the patient. Patient has to come to us, and we should offer, multi approach. Like people from different specialties should come to the patient, and everything has to revolve around patient. So these patients are different. They have rare diseases. So it's I think we have to really engage and participate, as you said. We have to be our own leaders trying to make that happen.
I think that sometimes the light bulb just doesn't go on at times. And as she was speaking about, you're seeing this one specialty, they're focusing on the thing that they're doing. And so my daughter has sickle cell. She's going to the hematologist stating that she has pain, and I'm constantly taking her there. They're doing everything they can, and they said, no, you really shouldn't be at this level of pain. I'm telling the doctor that at the same time that I've been taking her to the eye doctor because of something going on with her eye. They're, oh, okay. And then I'm taking her to the pulmonologist because she was having difficulty breathing. That doctor put her on oxygen at night. The eye doctor put her on some drop. I'm steady taking her back to the sickle cell doctor. But at no point is anyone saying, well, what else does she have going on, and connecting all of this together. It wasn't until I took her to a rheumatologist that said, that's sarcoidosis. Like you're giving me all of the symptoms of, you know, the eyes, the pain, the breathing issues. And so he diagnosed her with something else, but even though I'm taking her to all of these physicians, no one was paying attention to the fact that I'm saying she's going to these doctors for all of these other, they were just focusing on their sole specialty.
So there continues to be opportunity.
I think it's also important that we teach our kids, they are very much their best advocate. You know, going into the cardiologist saying, okay, I'm signing this release. I want you to talk to my neurologist. And the next time you go in, did you talk to my neurologist? Talking to the neurologist, say, did you talk to this person? And we gotta teach them that.
Well, I think that we could talk about this all night. But unfortunately, I want to be respectful of everyone's time and thank panel too. Thank you guys so much for your time this evening. Thank you for everyone who joined us virtually and for everyone who's here in person. We're very grateful for your support this evening and for you. We hope that this presentation was learned a little something and maybe got some insight that you didn't have before. Please check out United for Rare, check out Rare and Black, and if you haven't already done so, please sign up for our newsletter at Missouri Cares. Thank you.